Hi. Okay, that's me giving you guys a hug. I hope you guys are having a great time. You know, I've been to a lot of tech and design conferences. I don't think I've ever seen one where the lineup of speakers were predominantly women. So hats off to Gina for pulling that off. You know, and to you guys for being here. On that note, I'd like to share like a personal story with you guys. I started my career in academia at Boston University's Information Technology Department. Now, the IT department at BU was in the same building as the Math and Computer Science department. And in the basement of this building, somewhere, there was a supercomputing cluster that was running the physics department's research on, I think it was particle colliders. Anyway, it should come to no surprise to you when I tell you that I was probably among the 5 to 10% of women in the building at any given point in time. You get used to it after a while. Anyway, I was also only 19 years old. About a couple of semesters in, scholarships fell through. Family was going through hard times, couldn't afford college education, so I took on a full-time staff position. Sorry, I'm echoing and it's driving me crazy. It's like, is there anything I can do with this mic or somebody in the back tuning it up? Okay, sorry about that. I guess I'll just keep going and try to adjust. Where was I? Yeah, so I was the youngest full-time employee they'd ever hired. As you can imagine, it was kind of an intimidating situation in place for me at the time. And I made it a habit of mine very early on in my career that whenever I needed to muster up the courage to speak up and make my thoughts and ideas and opinions known, I would turn to data, something to substantiate it. And I mean, I guess you can say I found my professional voice through data, and since then, I've dedicated my career mostly to trying to make it more accessible. So I'm really excited to get to talk to you guys about data products in the context of design systems today. Before we get rolling though, I have a burning curiosity about you guys, because I'll be honest, I've been stalking you through the Slack channels for the design systems group. And there are some seriously, ridiculously talented and skilled people in this room, so it's very humbling for me to be standing up here. So I'd like your help with this curiosity. I'd like everyone to stand up for a second. Just for a second. Thanks. Okay. Is there anything you can do about this mic? This mic is like, okay. Okay, thanks guys. Okay, if you are currently not working on a design system, if you don't have a design system, and if you don't think you need a design system, please have a seat. Okay, so to like the one person who just sat down, what are you doing here? I was not expecting that. Well, welcome. I applaud your curiosity. Let me know if there's anything I can do to help. Okay, so to everyone else who's still standing, if your design system does not contain components for data visualization or analytic tools, please have a seat. Wow, there are quite a lot of people still standing. Where are your design systems? I haven't been able to locate them. But you guys can all sit down. I was just curious because I've been digging around. I'm not seeing any out there. Okay, so let's get rolling. Let's make sure this is working. Okay, so let's just start off on the same vocabulary. What are data products? According to DJ Patil, for me, a good definition of a data product is a product that facilitates an end goal through the use of data. DJ Patil is known as Obama's chief data scientist. At Salesforce, we knew him as a VP of product of Relate IQ. This definition sounds good to me, so let's go with it. But by this definition, wearables, self-driving cars, your Nest thermostat, those are data products too. Today I'm going to be talking primarily about web-based data products and primarily analytics software. Okay, what does it mean to have a design system for a data product? Are there examples? So I did do some due diligence, which is kind of why I had this curiosity. Uh-oh. Uh-oh. When did it cut out? I hope I wasn't talking too long. Okay. Okay. So, did a little research. GE has a great one. They even built their own charting framework on D3, IBM, ServiceNow, and then that was it. But now I know that you're out there, and that's all I could find. But I suspect you're still working on yours, and I suspect that because we're still working on ours at Trifacta. It's in development. And before I was at Trifacta, I was at Salesforce Analytics, and we also had our own internal design system on the Wave Analytics team. So after my disappointing search for more data design systems, including those that belong to data products, but don't address data design problems at all, I pondered over this question. Why aren't more design systems addressing the specific needs of data design? So being me, I tried to break it down to the different design disciplines involved with making a design system for data products. And you can usually suss out values held by each type of role based on their output and impact. I'm not going to read all of this, but here's my oversimplified assumption. Design systems design values beautiful, scalable products with strong brands and vision. User experience design is all about replacing painful problems with delightful experiences. Data design is about discovery, insight, solutions, and meaning derived from data. So I traverse between these two worlds. And if you're working on a data analytic platform or application tool, you probably sit on this boat too. So confession, there's an imposter among us. I am not a design systems designer. But it's a design systems conference, so I really wanted to talk about design systems. I am a user of design systems. I've contributed to them. So you can hear out my talk from the perspective of your number one customer. Very pro design systems. They've accelerated my workload, or productivity, I should say. Now, creating a design system for the user experience of data is very much a team effort. It's very rare that you'll find a designer who can traverse between each of these disciplines and operate at the highest level. I mean, each of these disciplines in and of themselves takes a lot of practice and experience to be good at. And frankly, I think these folks don't exist, with the exception of my friend and Trifacta colleague, the creative, hardworking genius, Giorgio Caviglia. But I digress. So there are no conflicts between the values of each of these design disciplines. In fact, they're very complementary. You can have a beautiful, scalable product with strong brand and vision while replacing painful problems with delightful experiences, and also offering discovery, insight, solutions, and meaning derived from data. So why aren't more design systems supporting the deeper problems of data design then? Well, I think one of the reasons why is because data design is hard. And not because most designers aren't trained in stats. although that certainly doesn't help. The hardest problems in data design aren't the mathematical ones. They're the human ones, the ones that require us to reference domains like psychology, cognitive sciences, fields that are yet still trying to evolve our understanding of human perception. I mean, consider why we visualize data. We visualize data because visualizing amplifies our receptivity and understanding of it. 70% of your nerve receptors are related to your sense of sight, making vision the most powerful and efficient means of consuming information for most people. So, I mean, understanding the different ways in which people perceive and learn and think and process and make decisions, that's just a general design problem. But I think it's one that is of particular importance when you're designing for data analysis or when you're designing for a data product that is collecting behavioral information from its users to drive machine learning algorithms. And somebody has to make sense of all of that. And I think it's these human factors that makes it incredibly difficult to reduce design problems down into a logical system. So now my question is, that will frame the rest of this talk, is how do we extend design systems to better support the user experience of data and the application of visualizations and analytic tools in our products? I'm not claiming to have the full answer to this, but I spent some time thinking about some of the design problems I've run into again and again, designing for exploratory data analysis and explanatory visualizations. And I came up with 6 ideas of ways you can approach your design systems design to help designers produce better data products. You can think of them as suggestions, just thoughts, ideas. Some of these ideas are very specific to data design, and some of them can be applied to any design system. Chances are good, most of you are already considering things like this in the design of your design systems. Okay, these are the first 5. I'm going to go through each of them one by one with some quick examples. So, number 1, identify the cognitive preferences or objectives of your primary users. Understanding how your primary user thinks and processes complex information, quantitative information, doesn't just help the data designer who's adopting your design system. It can actually aid you in shaping your brand and design principles, right? Guiding your approach as you create reusable patterns. And if only if it were a binary problem and as easy as putting people into 1 or 2 categories. And we all have a habit of doing that. In fact, most data companies I've either consulted or worked for, they tend to group people into technical or non-technical, right? But the truth of the matter is most people fall somewhere along a spectrum, and characteristics on either side of the spectrum, they're not mutually exclusive. So when you're dealing with a platform tool and you're working with people with different mental models and different ways of solving problems, you try to make everybody happy. So when I worked on the query building tool for Salesforce Wave, we introduced this concept of 3-mode switching. Did everybody use like an HTML WYSIWYG editor back in the day? You kind of switch between like the code view and the visual view. So it's kind of the same idea. It's the same query, but you can kind of go back and forth, constructing it by manipulating a chart, building a table, or just writing out the SQL query language. And we have a similar type of toggling experience in the Trifacta product. Some of our users have a preference for viewing script syntax in a UI. Others find it too technical and prefer natural language. So we just make it possible to toggle between the two. One of my favorite visualizations of visualization preferences comes from Alberto Cairo's book, The Functional Art. And it's basically 2 wheels, visualizations preferred by scientists and engineers versus artists, designers, and journalists. Now, like, I took this picture from my book because I couldn't find a digital image of it online. So I'll just read it out to you because it's probably hard to read from where you're sitting. So, first wheel, visualizations preferred by scientists and engineers. They tend to prefer visualizations with more abstraction, functionality, density, multidimensionality, originality, novelty. Visualizations preferred by artists, designers, and journalists. Redundancy, familiarity, unidimensionality, lightness, decoration, figuration. I pulled this from, I think, a Bootstrap template of dashboards. So just a quick note. It's best to avoid curves in your line charts. Unless you're graphing a polynomial function, you're basically implying points on the graph that don't actually exist when you add curves to your lines. Sometimes it's better to appeal to the cognitive objective of your product rather than the cognitive preference. So in cognitive sciences, one of the most enduring schools of thought is something called dual process theory. And I don't know if you guys have read Thinking Fast and Slow by Daniel Kahneman. Yeah? Oh my God, so few hands. It's an amazing book. It's one of my favorites. I highly recommend it. Anyway, dual process theory in cognitive science asserts that our brains form thought by means of two different processes. One process is deliberate, conscious, and the other is an automatic, conscious. So Daniel Kahneman divides into these thinking processes for decision-making into these two different systems. While both systems are always on, it's one system or the other that will take control and make decisions. So in simple terms, we either make snap judgments or we mull things over carefully. So how does this apply to design? Let me show you an example of what it means to design for System 1. Weather app. There is actually a lot of data that goes into weather forecasting. But these are automatic everyday decisions. I'm just checking out the weather to figure out what to wear today. I don't need to look at the Doppler radar data or the barometer. I don't need all of that. Just the little image of the cloud and the sun, that's enough. But both systems have their drawbacks, and System 1 can be a little error prone. Now, have any of you ever checked the weather, saw that it was going to be sunny, stepped outside and found that it was cold and rainy? It's when System 2 kicks in. Digs a little deeper to make a conscious decision. Do I go back inside for a coat? I might find out that the rain will let up in like an hour. It's not kind of worth my time. So I think as user experience designers, we always lean toward designing for System 1, and that makes sense, right? Don't make users think, make their lives easier. But what are some examples of where one might want to design to engage a person's System 2? Do you ever see what an air traffic controller looks at? I don't know about you, but if he was looking at an interface that resembles the sparseness of this graphic, I'd be a little concerned for my safety. So you can deliberately make an interface a little more dense to get your users to slow down and engage in System 2 processing. Okay, point number 2, or idea number 2, optimize for the efficiency of visual perception. And you can accomplish this through the thoughtful application of your design system's visual language. So just pulling up from some visual grammar, I'm going to go through a color example. I'm not going to talk too much about color. Diana Monter from GitHub is going to be talking about color systems tomorrow. It's going to be an amazing talk, so you don't want to miss it. But I'm going to talk about color in the context of visualizations. Color is very important and special to visualizations because it's a visual property that's pre-attentively processed by your brain. Let me show you what I mean by that. How many of these squares have rounded corners? What if I do that? Way easier, right? Notice the difference. You get color without having to think about it. And color can be used to encode multiple dimensions in your visualization. You can even remove labels from an axis through the use of color. Now, if this room is a representative sample of the general population, about 5% of you will find this completely unusable because it looks like this to you. And I say 5%, color blindness actually affects about 8 to 10%, but 5% because this was run through just one of the types, the green cone abnormality, deuteranopia. So choosing color palettes for accessibility and color blindness is actually really hard, especially if your visualizations are multivariate, multidimensional, and you need a strong palette. But it doesn't have to be ugly. They're usually ugly. It doesn't have to be ugly. Let me show you an example of probably my favorite accessible color palette. This is done by one of my very talented friends and former colleagues, Eli Brumbaugh, for the Salesforce Wave Analytics launch. It's a 22 color palette that's accessible. And it actually looked good with the brand color. So, pretty remarkable work. Here's what that palette looks like through the filters of each of the types of color blindness. Oh, and important to note, like it's shown in this way in his graphic because most charting frameworks will take in your colors as an array, so the ordering matters. If you're charting mostly 1 or 2 dimensional charts, most users will only ever see the first 2 colors. And it's like he was psychic, it just kind of worked in all of the marketing material. Anyway, so there's an example. Okay, idea number 3, create guidelines for displaying content based on machine learning recommendations. Okay, so the most well-known examples of machine learning, I'm gonna say ML, generated content appear on like e-commerce sites, social media, entertainment sites, right? Like people you might know, things you might want to buy. Some recommendations are pretty obvious and others are just baked into the experience. Like you don't realize that 75% of what you watch on Netflix is driven by machine learning algorithms. There are some UIs that visually highlight ML-based recommendations in some consistent way. Salesforce uses this Einstein logo in the product where recommendations are placed. I suspect the guidelines around this will appear in the Lightning design system at some point. At Trifacta, we use machine learning in combination with predictive interaction, helping a user complete their intended task. By interacting with a data grid, a set of suggestion cards will appear on the right. It's a very consistent interaction pattern. Suggestions are always shown in cards. They're always grouped by the type of transform. You always get a preview of the results in a yellow highlighted column. Copy, voice, and tone can go a long way for ML-based content. To illustrate this, I'd like to compare the messaging between 2 location-based push notifications that I've actually received in the past. Okay, the one on the left from Soup Shop. Lynn, you are 100 meters away from our store. Get a 10% discount today using your 300 loyalty points. That's a little TMI over the fact that you have a little TMI on me. I mean, and compare and contrast that to Foursquare. Near Tropisueño, your friend Joey says, try the carne asada burrito. What a coincidence, I am near Tropisueño, and a burrito sounds amazing right now. See the difference? Okay, number 4. Design and build for extensible, configurable, typo, there we go, and composable visualizations. If you've ever written data visualizations, especially on D3, probably found yourself writing a lot of the same code over and over again. Luckily, most charts can be easily modularized, and separating UI elements of visualizations into components, I think, works quite naturally. In fact, there are many open source visualization frameworks built on D3 that are built for reusability that you can look at. If you're looking for an open source visualization framework that's well architected for usability, I highly recommend looking at d3.chart. It's probably my fave. Okay. Writing usage guidelines for visualizations. My advice is to consult with a domain expert, if you can, because it can get kind of tricky. Okay, let's use the ubiquitous line chart as an example. It's like one of the most simple charts. Everybody knows how to read a line chart. It's also often called a time series chart, where your x-axis is always a time dimension. And most best practices assert that x-axis should always be continuous and ordinal, a continuous and ordinal value. But that's not always the case. Line charts can actually work with discrete and nominal values. Nominal meaning unordered. I see a few furry brows in the audience for me saying that. If you added a grouping to that time dimension and break it out into small multiples or a trellis chart, the dimension on the x-axis actually becomes discrete. And you're probably thinking, I don't know what you're talking about, it's still continuous, all you've done is broken it out to years. If I filtered this and removed the 2 years in the middle, 2011, 2012, and suddenly we were just comparing trend lines between 2010 and 2013, it would still be a valid visualization. It'd be like, it's still okay, they're discrete. It still works. So even a seemingly simple and basic chart can get a little tricky and nuanced when you're writing guidelines for it. So work with the domain expert if you can. Okay. Number 5, address the exceptions, the special snowflakes. If you don't know what a special snowflake is in the context of design systems, Google Brad Frost's Atomic Design. So many design systems teams have a process for bringing in new components. You know, like there's a process they go through. But I haven't really come across any design systems team that like actively address when it's okay to stray away from the design system. In fact, I've run into situations in the past where I'm not actually providing the best design solutions for my design because I'm trying my best to make use only of the components available to me for whatever reason. So make peace with data's special snowflakes, understand their problems, embrace them, support their innovation, believe in them. Here's a couple examples of a special snowflake. Well, first let me give some context. In 1985, Microsoft gave birth to Excel. Sorry about that animation, I couldn't help it. I just learned how to animate in Keynote the other day. I mean, Excel's been around, and it predates some of us. It's crazy, right? What's crazier is that it's still the world's dominant tool for working with data. Our global financial systems run on Excel. Don't get me wrong, Excel is an incredibly powerful tool, but it doesn't scale. Data has grown and changed at a faster rate than Excel has. And Excel has created this interaction design problem for anyone who's designing analytics platform products. The paradigms for working with spreadsheets and tables and using direct data manipulation has been so hard ingrained in most users. It's just second nature to them. So getting them to shift is an incredibly difficult task. When you're dealing with hugely unstructured data or truly big data, this interaction model isn't just horribly inefficient and infeasible. It's not even possible sometimes. I mean, try loading 500 million rows of data into Excel, right? Macros won't help you. So to solve some of these problems, many have explored innovative new approaches to interacting with data tables. Like Trifacta has its predictive interaction model, which kind of showed you a little bit of earlier. To solve some of these, okay, so on the upper left-hand corner of this slide is our actual table component in our design system. But we also have a table-like interface in the transform tool that's very different. This is our special snowflake. It's innovation. Another special snowflake in the name of innovation. On Salesforce Wade, we had our own proprietary charting engine called Eclair, where you can actually interact with the data visualization itself to modify the underlying query rather than interacting with controls elsewhere in the UI. Okay, so wrapping up soon, let's kind of review. Identify the cognitive preferences or objectives of your primary users. Optimize for the efficiency of visual perception. Create guidelines for displaying content based on machine learning recommendations. Design and build for extensible, configurable, composable visualizations. Number 5, address the exceptions, the special snowflakes. So number 6, because no design system is complete without guiding principles, right? So here's my suggestion for yours. Practice integrity. And I have to quote Edward Tufte because I do in every presentation. Analytical presentations ultimately stand or fall depending on the quality, relevance, and integrity of their content. And by practice integrity, I mean both data integrity and graphical integrity. If your data is of questionable quality, however slight it may seem, the repercussions of building on a product on top of that can be severe. Remember Apple Maps in 2012 that launched with iOS 6? Apple Maps was a data product with an unfortunate start. It had a lot of bad data. This was 5 years ago. I'm sure they've come a long way since, but do you know anybody who uses Apple Maps? It's really hard to go back when you lose the trust of your consumers. So if you're building modern platform tools for working with data, you can take the postmodern approach to truth where everybody gets to have their own view and version of the truth. There's a little bit more leeway. If you're designing things like reports and dashboards, these detailed, minute design decisions that you make to obfuscate the data or create perception bias, however innocent it may seem, you're essentially lying to your users. And I mean, consider the fact that most people look at data to make decisions. When you lie to someone in this context, you're depriving them of the ability to make the right decisions for their businesses and customers, for themselves and their families. Not to get dramatic. And look, it's never been trendier to be truthful. The whole world is moving towards transparency. We're seeing evidence of this everywhere. And it's probably one of the biggest reasons why I'm so proud to be a member of the product and design team at Trifacta. I mean, we're solving some of the hardest, most unsexy problems in data to accelerate the productivity of data professionals. And it's through that effort of structuring and cleaning and preparing your data for analysis that you move closer to good data quality and integrity. And I'd be remiss if I didn't thank my fellow design colleagues at Trifacta, some of whom are here today, and to express my gratitude, especially to Phil Vanderbroek and Giorgio Covilia for providing me with unrelenting support, mentorship, and camaraderie since I joined a year ago. We are unfortunately not hiring right now, but if you're interested in working with us in the future or interested in hearing more about how we're developing our design systems, don't hesitate to connect with us later. And that's it. Thanks, guys.
Okay, so my first question is about how did you get interested in data design?
It happened at BU kind of by accident. As I mentioned, when I opened this talk, I was 19 years old. I was like, I was pretty intimidated, a lot shyer back then. And it was a technology department that I was working in. So it just became a habit, working with the people I work with, and it was also very academic. So, if you disagreed, you had to prepare yourself for a healthy debate. That's just how it goes. And there was this one incident where I kind of uncovered a very complex problem in the university accounts provisioning process. It was actually kind of a big deal. It was a multi-million-dollar problem, and I got my point across by visualizing it. I didn't know it at the time, but I made a heat map. I didn't know what a heat map was at the time, but it just made such an impact. It kind of led me to work on some interesting projects while I was there. So, just been keeping at it.
Very cool. What advice would you give to designers and developers who want to learn more about statistics and data?
Find some buddies.
Yeah, so like mentorship or finding friends who are interested.
Just reach out. I mean, you guys, we're all resourceful. Find meetup groups. Start in meetup groups.
That's a great point.
Yeah, find people to follow. Look up what they follow. I mean, do everything that you do now to learn about visual design or user experience design. It's just kind of a different group of people. There's quite a community too.
You mentioned the book Thinking Fast and Slow, which is a great book. And I love book recommendations, so I'm wondering if you had any other recommendations that you've enjoyed.
Oh man, so many, like in what context?
In that field of like how people think and...
Designing with the mind in mind.
Designing with the mind in mind.
Yeah, I can't remember the name of the author off the top of my head, but that's a really good one. It's one of my favorites too.
Okay, cool. Thank you so much. Thank you, Lynn.
Thanks, Una.